In this lesson, we're going to learn about refraction and lenses. We'll learn what refraction is, why it happens, the difference between convex and concave lenses, how light behaves when it's refracted through concave or convex lenses, and what the focal point and focal length of a lens are. Refraction happens when a wave bends as it passes through a boundary between two different mediums. In the photograph, you can see a ray of light going from air into a block of glass and then back into the air. Each time it passes into a new medium, it changes direction and the ray of light bends. Refraction causes different interesting phenomena to happen that we see every day. If you've put a straw into a glass and seen it change direction in the water, that's refraction. Sometimes refraction can even cause big changes in the appearance of the size or the shape of something in the water. Refraction is how prisms work, because each color of light refracts a little bit differently than the other colors, so they're separated on the other side of the prism. And lenses use refraction to change the direction of light rays. We'll look more at lenses in a moment. To see how refraction works, imagine that you are running with your arms spread wide out to the sides. As you pass your friend grabs your left arm. What's going to happen to you? You're going to turn towards the left where your friend grabbed your arm because they slowed that side of you down. The same thing happens with waves as they travel at an angle into different mediums. Remember that waves travel at different speeds in different mediums, so as they pass into a new medium, they're going to speed up or slow down. In the image on the screen, the wave is coming from the left, and on the right it's going into a medium where it travels slower. It's like the wave's friend grabs its arm and slows it down on one side, so it turns towards that medium. The same thing happens in the opposite direction if the wave moves into a faster medium. Concave and convex lenses have different shapes. A convex lens is thicker at the middle and thin at the edges. A concave lens is thin at the middle and thick at the edges. When light shines through concave and convex lenses, they act differently. The convex lens refracts the light so that the light rays converge together. Means they come together at one point. A concave lens refracts the light so the rays diverge. That means they spread apart. The place where the parallel rays of light converge after they refract through a lens is called the focal point. And if you measure the distance from the center of the lens to the focal point, that's called the focal length. Diverging lenses, like concave lenses, also have focal points. The focal point of a concave lens is where the light rays that diverge out from the lens appear like they're converging on the front side of the lens. We've looked at refraction, which is when a light bends as it passes through a boundary between two different mediums. We saw that refraction is because waves travel at different speeds in different mediums. We learned that a convex lens is thick in the middle and thin at the edges, while a concave lens is thin at the middle but thick at the edges. We saw how light rays refracted through a convex lens converge together, which is why it's called a converging lens. And light rays refracted through a concave lens diverge apart, which makes it a diverging lens. We saw that the location where the rays of light converge after going through a lens is called the focal point, and the distance between the focal point and the lens is called the focal length.